Hello students, in this video you are going to learn about the various method of preparation of ethyne. Okay, so as you know that ethyne is the first member of alkyne and it is also known as acetylene, right? It is also known as acetylene. So let me make here the structure of ethyne for you at first. So ethyne can be shown in this way, C triple bond C, okay. or you can also show ethyne in this way, right? CH triple bond CH. Okay, now the first method, that is by the hydrolysis of calcium carbide. Now what is the formula of calcium carbide? Formula of calcium carbide is CaC2. Okay, the formula of calcium carbide CaC2. Now as you can see here in this picture, so this picture shows calcium carbide pieces. So it looks like rock pieces, right? Rock pieces. It is solid in state, and now when we put water, when we pour some water, simply water over these calcium carbide pieces, then ethyne gas will be formed. So it is very easy method of making ethyne. So simply put some water over these calcium carbide pieces and we will obtain ethyne gas. And if it is in powder form, the reaction will be more faster. If this calcium carbide is in powder form, surface area will increase, rate of reaction will increase, so reaction will be more faster. So to increase the rate of formation of ethyne gas, you can change this into powder form, right? So let me write the chemical equation, H2O, okay, calcium carbide plus water. So they will react and produce ethyne, CH triple bond CH, and as a byproduct, calcium hydroxide will be formed. Now for balancing the chemical equation, we can put here 2 and the reaction is balanced. So in this way, ethyne gas can be produced by using calcium carbide. Now moving on to next slide, the next method, that is from chloroform or iodoform. We can prepare ethyne gas either from chloroform or from iodoform. What is chloroform? The formula of chloroform is CHCl3. Let me change the color of this ink. Okay, CHCl3. And formula of iodoform CHI3. Okay, CHCl3. So here, this is the picture of chloroform. It is a colorless liquid. Okay, so generally it is kept inside the brown bottle in the lab. And this is the picture of iodoform CHI3. Chloroform CHCl3 and iodoform CHI3. And iodoform is a yellowish solid. All right. And you may be wondering, what is this? This is the silver powder. What is this? This is silver powder. So this is again a very easy method for preparing ethyne gas. We can obtain ethyne gas simply by heating chloroform with AZ, silver powder, or simply by heating iodoform with silver powder. Okay, now let me write the chemical equation for you. So we can write chemical equation in this way: CHCl3, chloroform, and silver powder, okay, AZ, when they are heated, gives ethyne, CH triple bond CH, and as a byproduct we will obtain AgCl. Similarly, from iodoform we can write CHI3 plus Ag, and you will get CH triple bond CH and Agi. Okay, so in this way we can obtain ethyne from chloroform or from iodoform. Now for balancing, 2 carbon on the product side, you can put here 2, and 3 to the 6 chlorine on the reactant side. Now you can put here 6, and 6 Ag on the product side. Now you can put here 6. So now it is balanced completely. Similarly here also 2, 6, 6. So in this way we can obtain ethyne from chloroform or from iodoform. I hope you understand. Now moving on to next slide. Now third method, that is from 1,2-dibromoethane. And this first picture, it is the picture of showing picture showing 1,2-dibromoethane. 1,2-dibromoethane is a colorless liquid. Okay, at room temperature it is colorless liquid. Similarly, this next picture, this is the picture of KOH. KOH. And third picture, this is the picture of sodium amide. Sodium amide. Picture of sodium amide. Sodium amide is a stronger base than KOH, potassium hydroxide. You know that KOH is also base, but NaNH2, sodium amide is stronger base than potassium hydroxide. Now, let us write the chemical reaction. Let me show you chemical reaction. Okay, so this is the chemical reaction of preparing ethyne from 1,2-dibromoethane. In the first step, you can see here, this is 1,2-dibromoethane, 1,2-dibromoethane, right? So 1,2-dibromoethane. And when we put this 1,2-dibromoethane in alcoholic KOH, then there will be dehydrohalogenation reaction. It means hydrogen atom and this bromine atom, they will be eliminated from the molecule at first, and one bond will be formed here. Okay, so this intermediate compound will be formed. We call it vinyl bromide. Okay, vinyl bromide. Now, after that, when we treat this vinyl bromide or resulting mixture with sodium amide, when we put sodium amide on this resulting mixture, then again one hydrogen atom and one bromine atom will eliminate from the molecule, one new bond will be formed, and finally ethyne will be formed. And here I have not shown the byproduct in each step, so let me write here byproduct. In the first step, byproduct will be minus KCl and minus KBr, minus KBr is byproduct, and H2O as a byproduct. Okay, and in the second step, the byproduct will be minus NABr, and then NH3 will be obtained as a byproduct. Now, this reaction can also be done by using sodium amide only. So, since it is a strong base, so instead of using KOH and then again changing the base, we can directly start by using sodium amide also. So, when we use sodium amide, 2 mole sodium amide, then first mole sodium amide will be consumed. Hydrogen atom, bromine atom will eliminate from the molecule. One new bond will be formed here. Again with next sodium amide, again another bromine and another hydrogen will be eliminated, and again one new bond will be formed here, as in the above reaction steps or sequence. So instead of using KOH and then NaNH2, we can directly use sodium amide also. Okay, so in this way also we can obtain ethyne. So I hope you understand. Now moving on to next slide. Now the fourth method, that is from carbon and hydrogen. It is also called Barthelot's synthesis, after the name Marcellin Barthelot. Okay, Marcellin Barthelot. He was from France. Okay, so in this method, let me explain the process to you at first. So in this method, carbon electrodes are taken, and high voltage is applied to these carbon electrodes. Okay, and when high voltage is applied, so electric spark will be produced here. When the current tries to flow from or electron try to flow from one electrode to another electrode, electric spark will be produced. And when hydrogen gas is passed through this electric spark, now this hydrogen gas will react with these carbon atoms and ethyne gas will be formed. So there is very high temperature here in this region, about 3000 degrees Celsius. And in this very high temperature, so carbon combines with hydrogen and forms ethyne gas. So let me explain by writing the chemical equation also. So carbon, that is present in the carbon electrodes, and hydrogen they combine in this electric spark region, where there is electric spark, and very high temperature is there in that region, and in that high temperature ethyne gas will be formed. Okay, so in this way ethyne or acetylene is produced by Barthelot synthesis. Now for balancing, you can keep here 2, and the reaction is now balanced. So these are 4 methods of preparing ethyne. I hope you understand well. You can repeat the video and watch again. Okay, now let's see some important questions. Question number 1. Complete the given reactions. So here aluminium carbide plus water, and you have to find the product here. And when aluminium carbide is given, when aluminium carbide reacts with water, it gives methane. Okay, it gives methane and aluminium hydroxide as a byproduct. You can balance it by yourself. Calcium carbide plus water. So just now we learned it produces ethyne and calcium hydroxide. Yeah, calcium hydroxide as a byproduct. And magnesium sesquicarbide reacts with water to give propyne. Okay, be very careful here. There are 3 carbons here, so it gives propyne. CH3, C triple bond, CH3C triple bond, CH. Okay, propyne, and plus magnesium hydroxide here also. So in this way, so don't be confused here. When there is calcium carbide, ethyne is produced. When there is aluminium carbide, methane gas is produced. And when there is magnesium sesquicarbide, propyne is produced. Okay, so sometimes such question may come in exam. Now question number 2, you try this as your homework. What happens when chloroform is heated with silver powder? So I have already explained. You try this yourself. Write the language is very compulsory. When question is asked in this way, what happens when chloroform is heated with silver powder? So when question starts with what happens, you write the language at first, and then you write the chemical reaction, and show it to your teacher. Do it by yourself. Okay, now question number 3, identify the products. So first question number A, iodoform is given CHI3 and silver heat. So the products will be CH triple bond CH ethyne and AgI as a byproduct, right? So this byproduct you can skip here when the reagents are given above the arrow like this. Okay, you can skip writing this byproduct. Similarly, second question, 1,2-dichloroethane is given and 2 more sodium amide is given. So here one by one there will be dehydrohalogenation reaction, and ultimately ethyne will be formed here. And byproduct, no need to write, or if you want to write also no problem. If reagents are given above the arrow, then you can skip writing byproduct. Okay, but if you want to write, you can write, no problem. NaCl. So NaCl will be formed and ammonia will be formed as a byproduct here.